Hi, welcome everyone to session 11. So in this session, we will discuss about model deployment. So once the model has been identified, validated and accepted, now the model can be actually deployed for consumption, right? We can send a request to the model and the model with necessary information and the model will respond with the prediction. Now, there are two approaches that we will explore here in this session. One is deploying the model as a service, like an endpoint. Like we can send to an HTTP URL, RESTful API, with the necessary information about the car. We'll take the example of predicting the resale value of an used car. So we'll send a JSON message with the necessary information in a JSON format, and the model will respond back with the what is the expected sale value of the car. And then we'll also explore how to create a web interface for the model deployment, which will be probably necessary or useful for creating a quick demo or even for deploying in the production. So once the model is developed in the learning system or training system, and we have experimented with multiple models, let's say the model M3 is selected, now we will store or serialize the model into a pickle file. So this is something that we have already explored when we discussed about creating ML pipeline. So if you have not seen that, please go ahead and watch that video. So we leverage that pickle file. So in this session, we are not going to create a pickle file anymore. It's already created in the previous session. So we'll leverage that pickle file and then load that pickle file into an inference system. So when we load that, we'll actually create a service, right, with an endpoint. So the model runs a separate service and is integrated through an endpoint. And the endpoint, nothing is but an URL where your service can be accessed by a client application. So a consumer, like an API, will sends an HTTP request saying that, okay, here are details about the car in a JSON format. So the endpoint actually expects the request to come in a JSON format. And then it sends all the details about the car, and the model will predict based on the model that we have loaded here, and then sends back the response with the expected resale value of the car. So for this, I have already uploaded the 3 files here into the session 11 of the GitHub. So 2 files are for model deployment as a service. So this file will be actually creating the model as a service, and this will be using as a client to invoke that particular service after it has been deployed. And the third file is, of course, to create a web interface, and this is the pickle file that we are already created. So I've already given that pickle file. So let's go ahead and open the session 11 on your local system, and then click on the model deployment as a service. So deploy the model as a service. For this particular exercise, we will be actually using a Flask framework. A Flask framework is a web framework. It's a Python module. It's actually developed, written in Python to develop a web application easily and quickly. Of course, this is not a session to explore Flask per se in detail. We'll only look at to sufficient features of the Flask, which is necessary from the point of view to deploy a model as an endpoint. So let's look at the code again. So let's import pandas, numpy. We don't need actually a joblib import load. So this is necessary for deploying the model. So from Flask, we'll import Flask, JSONify and request and import JSON. We have to first load the model, the pickle file into memory. So we'll create an app. The first we'll create an app, the Flask, and app.model object. So this is of course a variable that you can define on your own, whichever variable name. So in this case, defined as a model object, and then load the model onto this particular variable. And then there are two methods that we have defined. One is for the home page, which is like a index page or the root page. So for example, if you want to simply send a request to like http colon and the URL, the IP address and the port number and a slash, so that will actually arrive at the root page. So if you send a request to that with a get method, of course, without sending any other information or message, so this is going to send you back a help information, how to invoke the actual predict URL. So he's saying this is a car prediction app. So send a message to this particular endpoint slash predict and post a message in the JSON format like this with necessary information for the car. So we can define app.route. So this is default page, and we'll define a method called home. So when you send a request to the default, the slash is going to send back a simple message how to actually use the endpoint. And then this is the actual URL endpoint where the model is deployed. So we'll create a endpoint slash predict, and this will be post method because we're expecting actually a message, a JSON message, and we'll define a method called predict. So here, when the request comes in, we will first load that request data. So if the message comes like this, so this should be loaded here as a JSON message. And then we'll convert that into a data frame first, because our predict method of the model is expecting a data frame object with, of course, one single row with the index 0. And then we will invoke the model which we have loaded here from the pickle file here. If you see the model object, all that we have to do is basically saying that dot predict and give the data frame. So this of course predicts the car price, and then we will create a message saying that resale value or sale price is the car price, and we'll JSONify and send back the HTTP response. So this is the actual endpoint that we're creating at the IP address port number slash predict, and we're receiving a JSON message. We're converting that into a data frame and call predict and send back the response. And now this code, once we execute that, and then we can say app, which is your Flask, run at a particular port number, like 5001 here, and then start the service. So you can see it's running on this particular port now, 127.0.0.1 local host in 5001. So if we click on this, so this is the root page. So you can see it sends back the response saying this is a resale car price prediction app. So send a request to this particular endpoint now and post a message with this particular JSON format. Now, how do we invoke this now? So of course we cannot do it through the web page. So we'll create a application for that, client application. So there is another notebook here called invoke prediction service. So if you open that, this simple HTTP client application which will actually send a message to a particular URL. So here you can import request and JSON, and here of course I have hard coded the actual message. So this is the car, the fuel type is diesel, the transmission is manual, the owner type is first, first owner, it's an 8-year-old car, it's a Ertiga model, and it's driven 87,000 kilometers. Now, can we predict the resale value, or can you estimate the resale value of this particular car? Then all I have to do is basically convert that into a JSON, replace any new line characters are there, and then this will look like this now, the JSON format. Then all I have to do is say request, which is basically HTTP request, post a message to this endpoint, because this is where the model is running. If you see here, this is where the model is running, 5001, and slash predict, and send the JSON message. And once you send the JSON message, it sends a response back, and it sends a response with a code of 200, and we know HTTP 200 basically is the successful. And then if you look at the response JSON, it says the sale value of the car is 6.17 lakhs. This is the estimated price of it. So this is how the model has been deployed. So this is this particular code or notebook acts like an inference system, right, where the model is loaded onto memory and actually endpoint is created, and this particular code invoke acts like a client which consumes that particular endpoint and sends a request and receives a response back. So this is how it can be deployed. Of course, there are now cloud platforms like Azure or AWS have their own cloud platforms where you can deploy the model as an endpoint, which we'll explore a little later. But this is the foundation of how to create a model as a service. Now let's look at the third one, which is used car price app. So if you open that, now we can actually create a web app. For example, sometimes you may want to create a web interface for model deployment for POC or demo, or even for production. So let's say you want to provide a web interface, something like this, right? So there'll be a web page. So if you go to a web page, it will have all the fields. For example, the user can select what model it is, what transmission of the car it is, what's the fuel type, what's the owner type, and then what's the age of the car, and how many kilometers driven in terms of 1000 kilometers. So the user can select all necessary information and say predict price, right? This is a wonderful way to quickly demo a models, right, to customers. So there are multiple different frameworks for doing this. One of the very popular framework is of course called Streamlit. So Streamlit is a faster way to build and share data apps. It turns data scripts in shareable web app in minutes, right? So we will utilize this particular framework. There is another framework also called Gradio, which is also quite popular. If you want to explore, you can explore, but I will show it using Streamlit. For this, of course, you have to install Streamlit. So you can say pip install Streamlit. I have already installed that, so I'll skip this step. And then creating the app. So this is the code to create the app. So it has two methods. One is called predict price, which will load the model and receives the necessary information from the fields on the web page, and then it'll basically it'll predict the price based on the model and respond back, right? This method will return back with the price. The actual app is the UI, the user interface is created in this particular function called app layout. So let's look at the predict price first. So import Streamlit, import pandas, numpy, and joblib load, which will load the model. So you can load the model first from the pickle file into a variable that's called car model, and then the predict price, the method which will receive all this inputs. So we'll send what the car model is, what's the fuel type, transmission, owner type, kilometer driven, and age. All the six inputs that we need to predict the price. And once we receive all this, we'll put that into a JSON message and convert that into a data frame here. So kilometer driven colon the input that we received from the kilometer driven, and so on and so forth, and convert that into a data frame with just one row or record. Then car model dot predict, and I invoke that particular data frame, and which will give the price and return the price of the car. This is of course a simple method which receives the inputs and predicts the price. But to develop the actual interface, we have to override this method app layout. So here, if you see the Streamlit, we have import Streamlit as st. So you can say, you can give a title to the page. It's very wonderful interface, APIs to create a wonderful web interface quickly. So you simply can say title, give a title to the page, give a header, and then it has specific APIs for creating different kinds of input fields, like a box input or radio input field, right? Or typically accepting numbers, numerical values, and so on and so forth. For example, a model, we can actually do a drop down menu. So select box. So these are the possible values. This is the first parameter is the name of the field, and the second parameter is the possible values depending on what kind of field we are using. So in this case, we are creating a menu, a drop down menu. And here's a radio button, whether the car is a manual or automatic, and this is the field name called transmission. And fuel type also radio, owner type is also radio. Age, we can actually create a numeric value, so you can actually create, you can click on the plus value to increase or decrease the value of the age, which is the how old the car is, and you can specify what's the minimum and maximum value is that we are expecting. Then the similar the kilometer driven, and once the user selects the value, the value is actually stored into this particular variable: model, transmission, fuel type, and all that. Then if st.button predict price, so we're going to create a submit button also called predict price. So if that is pressed, so that value is true here. So moment you press that button, it's basically true. Then we will take whatever the values are there in this particular field. Then we invoke this predict price here, this method. And we will pass all these parameters. And of course, it's going to return the price estimate, invoke the model to predict the price and returns that. And then we can display a message called streamlit.success. Expected resale value of the car is whatever that particular price is. We're rounding it up to 2 decimal values, and we're showing at the bottom of the page. And then there's a method main which will invoke this particular. So when you run this particular file, the app layout is called. So now this particular code has to be written to a file. So if you see, there is a directive here called percentage write file. So what it'll do is it'll write this particular code that's there in this particular cell into a file called app.py. Okay. Either you can create that independently or you can create through Jupyter Notebook. So if you want to create through Jupyter Notebook, you can write like write file app.py. So the moment you execute this, and if you go here, if you see it has created a file called app.py, we can run it now. Streamlit run app.py. And you can see that it's a web file is created. So enter the car detail, You can select the car. Let's say you can select the car, Swift car. It's automatic. Let's say it's a diesel car. It's a first owner, and let's say it's a 6-year-old car, and it's driven for, let's say, 50,000 kilometers. And then if you click on the predict price, it shows a message: the expected resale value of the car is 5.74 lakhs. So this is how you can create a quick demo using uh, Streamlit framework. And in this session, we've explored now two ways to deploy the model. One is actually model as a service and create a web interface. So thank you and see you in the next session.